Hey everyone, welcome back. So in the last video we had started the topic of array, but most of the array questions use other technique also to optimize our solution. So in the last video we used two pointers to merge our sorted arrays. So today we are solving question based on array, but it have other concepts also. So we have to learn these concepts while solving this problem. Okay, so our problem is container with most water. This is medium question from the Leetcode, and this question is using two pointers and greedy concept from the DSA, because you can write your brute force without using them, but we want to write optimized code. So without these concepts we cannot write a optimized code. So the pointer technique is that we use two iterator to simultaneously iterate over our array to find the answer. Similarly, in this case we are going to use two pointer I and j to find our answer. And KD concept is basically a problem solving approach in which we make a choice at every step where we can get a benefit. You can say, like, if you are buying a stock, now there are two types of benefits: long term and short term. So but you are greedy, you look for the short term benefits. So that's it is greedy algorithm, where we will look for a short benefit so that we can solve our problem. Now let's see what is our problem. You have given an array of height. You have to return maximum amount of water. Means we have given height. If you draw these heights, let's draw for the first, then for the height 8, then we have 6 here, then 2, then 5, then 4, here 8, 3 and 7. So these are our heights. Okay, now you have to return maximum amount of water. So it is saying that if you fill a water somewhere here, what is the maximum amount of water you can fill between these pillars of different height. Okay, let's say if you fill a water here between these pillars, so the maximum water you can fill here will be 1 into 6, right? Because the distance between these two pillars is only 1, and the height at which you can fill the water is 6. You cannot fill the water till here, because if you try to fill, it will overflow. So for these pillar, between these pillar, we can only fill 1 into 6, that is 6 amount of water. Okay, let's say if also we consider these pillar also. Now what is the distance between these pillar? The distance is 1 2 3. It is a 3 into. Now what is the minimum height at which we can fill our water? If you look at it, you can fill the water till this height. Beyond this height, the water will overflow. So this is our height 5. So 3 into 5, it will become 15. This much amount you can fill in these gaps. Okay, so what is the maximum amount of water you can fill? If you consider this stack, this one, you can fill 1 2 3 4 5 6 7. We have 7 distance into what is the height we can take. It is 7, right? If you try to take this one, the water will overflow from here. So we can only take 7. 7 to 7, it will be 49. So that's our answer. So you can say you have a place where you have a pillar and there is a rain is happening, or you are filling the water between them. So you have to calculate maximum amount of water you can fill between these pillars. Okay, every pillars have a distance of 1, so they are consistent, and we cannot make changes in the pillars, and also you cannot shift your pillars. So your pillars will sit there. You just have to calculate your maximum amount of water. So how we can solve this problem? So basically we are trying to check if we can store maximum amount of water, right? Let's say we iterate over all the pillars and try to find our maximum answer. Let's start from this one. This is my I, this is my j. Okay, if I find the answer between them, it will be answer equals to the distance we can calculate with the j minus I. J at the index 1, I at the index 0. So if you do a 1 minus 0, it will be 1. The distance is 1 into height. So we have two pillars. So which height we have to consider? We have to take a height of minimum pillar, right? If you try to take a height from the maximum pillar, the water will overflow. So we will take a min of height at the I and the height at the j. Okay, so if you calculate j is 1, I is 0, multiply min, we have height of 1 comma 8, so the answer will become 1, right? In this case you can only fill one amount of water. Let's move over j. Okay, now b will try between these two pillars, so you can say height will still be 1, so at max we can fill water amount of 2, right? Because this time our distance got increased, so 2 minus 0 into height will remain 1, so it will become 2, right? Because the distance is 2, so we can get only 2 answer. Similarly, if we move our j to the next column, you can fill your container with the amount of 3, because we have to still consider 1. Similarly here, then here, here, so the max amount of water you can fill from these pillars is 7 into 1, right? Which is 7, because only distance is increasing, height will remain 1, okay, if we are considering these pillars. So our max answer is 7 till now. Now the j completed its iteration. After j complete its iteration, we can move our I and j. Now we will try to find the max answer. So in this case our answer will be, the distance is 1, right? J minus 1, j at the 2 position, or I is the 1, so distance is 1. And what is the minimum height between these pillars? It is 6, so our answer will be 6. Now if we have a j here, our answer will be reduced because height is here 2, so our answer will got updated. Okay, so while finding the height we are taking minimum, while finding the answer we are taking maximum. So let's move to the next pillar. If we are at this, our answer will be, we can fill this and we can fill till here, so our new answer will become, the distance is 4 minus 1, it will be 3, so and the height we have here 5, 3 into 5, so it will be 15. So here between these new I and j we can fill our 15 amount of water. So let's directly move at this pillar, and the distance will be 6 minus 1, it is 5, and the height we can take here is 8, so it is 35, sorry 40. Okay, so between these I and j we got our answer 40. Now let's move our I directly at this, sorry j at this pillar. Okay, in this case I am skipping some pillars, but when you are writing a brute force code we are trying every possible way, so in that case it will be your nested loop. So nested loop will try your all the cases. So distance is 8 minus 1, it is 7, into the height we can take 7, right? This one is 8, this one is 7, we cannot take 8, so 7 into 7, 49. So this is our final answer. You cannot get better answer than this. So we created a formula to get the maximum amount of water, and we are iterating over our pillars. So the code will be for int I equals to 0, I less than n, I plus plus. Okay, this is for the ith. Similarly for int j equals to, this time we are not starting j from 0, we are starting from the I plus 1, right? Because we have to start our j from the next of the ith, so we are starting from the j plus 1, because between these two pillars you can check your amount of water, not with the previous ones. So here j equals to I plus 1, then j less than n, and j plus plus. Okay, here we are using j plus 1, so that means we will be going till n minus 1 here, right? So we will be going with the I till here, we won't be going to the last index. If you try to go at the last index, you won't find your answer, so we will be going till the I, and j will go till the n, so you can easily get a difference. So here we have n minus 1 and here we have n. Now we have one variable min height. You can take variable to store min height, or you can directly use this formula. Okay, let's directly use our formula. So we have answer equals to j minus I. It will give me a distance between pillars, and min of height at the ith and height at the jth. So it will give me an answer, but we are trying to find the max, so here we have to write max function of the answer also. So max of answer, max between the previous answer and the with the current answer. Okay, in this way we will be able to find our answer. Okay, what is the time complexity? It will be n square, space complexity will be 1. We are running nested loop. For the ith we are going till n, and for every ith we are going till the n, so it will be n square. Okay, so first let's write the code, then we will see how we can optimize this solution using two pointer and greedy algorithm. Okay, so this is our question. Here you can see this is our example, where you can see you can fill the water till this pillar, and the difference will be these gaps are the difference, and every gaps are of the difference 1. Okay, so let's write our code. So let's first declare size of array. Okay, and let's run our loop 0. It will be n minus 1 and I plus plus. Then for int j equals to 0, it will be I plus 1, j less than n, and j plus plus. After this, answer equals to max of answer. Okay, we have to declare here our answer also. Then here now we have to calculate our amount of water into min of height of I comma height of j. Now let's return our answer. So let's see it is working or not. So here you can see our initial test case got passed. Now let's try to submit it. Now here you can see we have total 65 test cases, but only 58 test cases got passed, and it is giving me the time limit exceeded. Okay, so our brute force solution is not working. Our time complexity is n square, right? And they have given me the n till the 10 to the power 5. So they have given n less than 10 to the power 5. That means there are 10 to the power 5 number of inputs, and we have written our code in the n square. If you put a value of n square, it will become 10 to the power 10. But when we calculate time complexity, we have to consider our code, so it will not exceed 10 to the power 7. So we have to keep our number of inputs less than equals to 10 to the power 7. If it become more than 10 to the power 7, it will give me a time limit exceeded. Okay, so that means we have to write our algorithm in the big of n, which is 10 to the power 5, which is less than equals to 10 to the power 7. So this will pass. So now how we can optimize our solution? For this we are going to use two pointer approach. We have to find the maximum amount of water between two pillars. So I will start one iterator from here and another iterator from here. Now I will check amount of water. Now before checking that, we have to consider the height also, right? Because height can make a difference in the amount of water. So if you take amount of water between these two height, it will be 7, right? Because the distance is 7 and the height you can take is only 1. So that means which height is creating a problem for us, right? Means you can say we can have a better height for this index, because this one is 7, which is greater than 1. So we are thinking we need greater height than this one height, so we can get our answer. So in this case we will move only I to the next index, not the j. We can say it is at the perfect height, but at the I it wasn't perfect because it was not giving me the solution. So that's the greedy. Means we are looking for the immediate benefits. So if you try to move our j, can you get the benefit? No. If you try to move our I, you will get the benefit. So now if you try to find your answer between these pillars, it will be 7 into 7 49. Okay, this one was 8. So that's how we are calculating the answer. So we are running two iterator I and j. Okay, and at which iterator the height is smaller, we need a greater height, so we will only move that iterator. If somehow let's say we have here height of 5, okay, let's consider. Now if we find the answer between them, it will be 7 into 5, it will be 35, right? Now you are thinking maybe there is a better height in which you can get the answer. So between I and j, which one is at the perfect height? Or you can say you will consider this height is better than this. So at the ith position we can say our height is good, but at the jth it is not good. So you will move our j to the next index. Now here you will calculate again. Now again you will think maybe this height is not the best height, so you will move again your j. So in this way you will move your j while comparing between heights, and you will stop your loop when your I and j will reach at the same index. So let's take a simple example. So you have something like this, okay, and here we can take 5 6, here 4, and this 5. So we have this example, we have I here and we have j here. So the answer here will be distance is 3, height you can take 5 because both heights are equal, so it will become 15. Now from both of them you can move any one of them, you have to handle in the condition. So let's say we will move our j. So we are saying if we move our j to the left, there may be a chance we can get a better answer. So that's why we moved our j. Now our answer is 2 into 4, it is 6, but 15 is a maximum, so answer will still be 15. Now this height is smaller, this height is smaller than this, so we will move our j. So our j will come here. Now again we will find our answer. The distance is 1 and the height we can take it is 5, so answer will still be 15. So now in this case the height at the j is greater than the height at the ith, so this time we will move over. Now I equals to j, we will stop our loop. Okay, so let's first write the code, then I will explain the code once again. So we have int I equals to 0, which we are starting from the first. Then we have j equals to n minus 1, which we are starting from the end. And we have answer, which is storing maximum amount of water. Now we will be running our loop, in which we will check if I have I less than equals to j, I will keep running my loop as j becomes greater than I. That means they crossed each other. If they crossed, we can stop our loop. Now we will check height. If our height of I is smaller, right, then we will take our height of I because it is a minimum. So our answer will become max of answer of the distance is j minus I into height of I, and we will move over I plus plus. So what we are saying, if we are at smaller height and j is at greater height, then we will take a smaller height and we will move our I. Okay, so we have to move the one which have a smaller height. So in this case we have a height at the ith smaller than the jth, so we will consider height from the ith and move to the next index. And the other case can happen will be for the jth, so we will directly write, because in this case we have only two cases, right? Height I will be smaller or height j will be smaller. So here j minus I into height of j, and here we will move our j minus minus because we are coming from the right to left. So this is our whole code. The time complexity will be big of n and the space complexity will be big of 1, because we are iterating every element only one time, right? I is moving from here and j is moving from here, so all of the element is only iterated one time. Only one pillar got iterated two times, so it will not create much difference, right? Because at this point we are stopping our loop. So this is our whole code. Okay, so let's write our code. So it will remain same. Let's use while loop here. Let's first declare int I equals to 0, int j equals to n minus 1, then while I less than equals to j. If height of I is less than height of j, then we will consider our height I. So it will be j minus I into height of I, and we will move our I plus plus. Else we will take here j and our j will move j minus minus. So now let's run it. So here you can see our solution got accepted. Okay, so you have to remember that if we are at the smaller height, we will move the index of that height and also consider that index. So we are greedily taking the next pillar so we can maximize our answer. So the time complexity is n, space complexity is 1. Okay, try run more examples so you will be able to understand. So that's it for today. Until then, thank you everyone. Have a nice day.